Hi everyone, I'm Gina, and today we are going to be talking about gluconeogenesis. Here we have the glycolysis gluconeogenesis template. However, I've removed the irreversible reactions of glycolysis so we can just focus on gluconeogenesis and visualize why the pathway is so expensive compared to glycolysis. I'm going to use this pink color to symbolize what is put into gluconeogenesis, and this blue color to symbolize what is made from gluconeogenesis. Since gluconeogenesis is the backwards version of glycolysis, we start with pyruvate, specifically 2 of them, since we're starting where glycolysis ended off. Just as a reminder, we will have 2 molecules of everything until we get to aldolase, where we join the 2 trioses or 3-carbon sugars to make F16BP. So now going enzyme by enzyme, we use 2 ATP to make 2 ADP and 2 PI in pyruvate carboxylase. Then we go to PepsiK, where we use 2 GTP and make 2 GDP. Since enolase is reversible, we would put in 2 waters, 1 for each PEP molecule, to continue going to the right. Phosphoglycerate mutase is completely reversible, so we can go through. Since we're going backwards through PG kinase, the arrow is going to go that way. So we're going to use another 2 ATP and make another 2 ADP. Now, since we're going backwards still through GAP dehydrogenase, the arrow is going to go this way, and we're going to get out a PI. So in this step, we use 2 NADH and H+, and we make 2 NAD+ and 2 PI. Triose phosphate isomerase and aldolase are both good to go, but now we've made 1 molecule of F6BP, so everything from here on out has 1 molecule. Now we get to FBPase 1. This is a hydrolysis reaction, so we need to put in 1 water to dephosphorylate and get 1 PI out. Phosphohexose isomerase is good to go since it's reversible. Finally, we get to G6Pase, which is another hydrolysis reaction. Therefore, we put in 1 water to get 1 PI out to make glucose, which is the final product of gluconeogenesis. Now that we visualized it on the template, let's go enzyme by enzyme again and put the products used and made in a list. So we start off the whole process by using 2 pyruvate molecules. In pyruvate carboxylase, we used 2 ATP and made 2 ADP and 2 PI. In PepsiK, we used 2 GTP and made 2 GDP. In enolase, we used 2 waters. In PG kinase, we used another 2 ATP and made another 2 ADP. In GAP dehydrogenase, we used 2 NADH and H+, and made 2 NAD+ and 2 more PI. In FBPase 1, we used another water to make another PI. And finally, in G6Pase, we used 1 last water to make 1 last PI. When we add all of these up, gluconeogenesis uses 2 pyruvate, 4 ATP, 2 GTP, 4 waters, and 2 NADH and 2 H+ to make a glucose molecule, 4 ADP, 6 inorganic phosphates, 2 GDP, and 2 NAD+. Thanks for watching.